Good morning, my dear students. So today we are going to talk about how you can display custom characters in LCD I2C. As you know, you can also show icons and emojis in the LCD screen aside from text. And we are going to talk about the functions that you will use in order to do so. Later on, we are also going to show a sample program involving displaying custom characters. Okay, so let's say you are tasked by your instructor to create this type of project. You can see that in this project, both of the rows of the LCD screen is occupied. The first row is occupied by a text that reads custom characters. And then on the second row, you can see the 8 custom characters that the programmer was able to create. So there's a bell and the music note, a side face, and so on. So if we create a pseudocode, we can say that the program is quite simple actually. We need to first display the text on the first row and the custom characters on the second. Now our main concern is how do we create these icons, these custom characters. First, I'd like to remind you that your LCD screen, 16 by 2 LCD screen, is composed of sort of like boxes or cells. There are, well, 16 of them in a row. That's why it's called 16 by 2. 16 columns of these cells in two rows. And if you look closely in each of these cells, in each of these boxes, you can see that they are composed of individual pixels. These pixels are 5 by 8. That means 5 columns like this, 5 boxes, small boxes like this, and then 8 rows. So a total of 40 per cell, right? And these individual pixels are the one you are going to activate so that you can form a specific pattern. Like for example, a heart as shown here. So you can see here that the first row here, the pixels are not activated. They are not blackened out, right? They are not darkened. And then in the second row, um, the first the first one is not, and then the second pixel is turned on or activated or blackened, and then the third is not again, and the fourth is again activated. The third row, fourth, and fifth row, all of them are activated and blackened out, and then the last one, meanwhile, is also not, all of the pixels there is also not activated. So in order to do this, in order to activate individual pixels like this, what you need to create is a binary matrix. So as you know, when we are dealing with binary, what would appear are numbers that are zeros and ones. So byte heart is the name of the custom characters that you gave it, the name that you gave it, because, well, you are forming a heart here. And an important observation that you can make here is that there are 1, 2, 3, 4, 5, 6, 7, 8. 8 rows of binaries. And then per row, there are 1, 2, 3, 4, 5, 5 zeros and ones as well. So that corresponds to the 5 by 8 matrix of your cell. Okay? So a 0 means that that particular pixel is not activated, and ones means that that pixel is activated or blackened out or darkened out. That's why here, the third, the fourth, and the fifth one here, they are all composed of ones because here in your original design, these are the pixels that are um, all of them activated in that particular row. And then you can see here that in the last row in the binary matrix, you only have zeros because, well, in these rows It didn't activate any. Okay. This is another example. Here is a bell icon. So all ones here because that's the fifth row here, which are all activated. And so this time you call this a bell. It's a bell because you're creating a bell. Okay, so now that you have designed your custom characters, the next thing that you would do is to actually create it or save it in the LCD I2C memory. Now, an important thing to remember is that you can only create up to seven, or rather up to eight custom characters in a single program. So what you do is there are eight memory slots in the LCD I2C, and you can save one custom character on each of those slots. So what you do here is use this function, the LCD that create car or create character. Take note that this is a capital C here, and then it would require you two parameters. The first parameter is a number starting from 0 up to 7. So 0 up to 7 corresponds to the 8 memory slots. We will start with the number 0 instead of a 1, and then comma. The second parameter of the LCD create car function is the name, the name of the custom characters that you designed from a while ago. So these two lines of code is creating or saving the character, the heart icon that you created, and the bell icon that you created a while ago. The third important function that you should use is the LCD.write. So the LCD.write is usually what you use in displaying text. But in order to show custom characters, you have to put byte and then inside another parentheses, the number corresponding to that particular character. So this means that this first line is going to display the heart icon, which you assign 0, and the second line will display the bell icon next to the heart icon, which you assigned 1. Okay? So those are the three most important functions. First one, you have to create the binary matrix to design the character, and then you have to save it in the memory slot using the LCD.create function, and you can now display it using the LCD.write function. Okay, in this part, we are going to show a sample program where you are going to show custom characters on an LCD I2C screen. So as you can see, the wiring is pretty simple. You will only be needing 4 jumper wires. Let me click Start Simulation to show you the program. So in the LCD screen, the first row must show the following text, Custom Character Test. And then in the second row of the screen, it should show two icons or two custom characters. The first one being the heart, and the second one, some sort of smiley face. So let's take a look at the code. So as you can see, you would put the byte or the binary matrix on the initiation part of your code. So right after the LCD libraries, you would put your binary matrix. So this is your binary matrix for the heart icon. The name of your custom character here is heart, and you can see the ones and the zeros, the 8 rows of ones and zeros. And then follow that up with your binary matrix for the second icon, which is the smiley. After that is your void setup. You would first need to turn on your LCD using the LCD.init function, and also the backlight of the LCD so that the texts are easier to see. After that, you can declare your LCD.create character functions so that you can save your heart and smiley characters. You are saving your heart icon on the first memory slot, assign 0 here, and your smiley on the second memory slot, assigned 1 here. After that, you would put your cursor using the LCD.setCursor function on the first column and first row of the LCD screen. That's why you can see 0, 0 here. You might be asking, why is it not 1, 1 if we are going to place the cursor on the first row and the second row? Please remember that in LCD I2C, we are using zero-based indexing. That means the first row and the first column will be called 0 and 0 instead of 1 and 1. So 0, 0 here means that your text would start appearing at the first column and the first row of your screen. And then use the LCD.print function to display the text custom character test. Take note that you have to put quotation marks. And then after that, so that you can put your custom characters on the second column, you will need again the set cursor function. This time, you want it to start appearing on the first column and the second row. That's why it's 0, 1 here. And then now you can display the heart character using the LCD.write. Byte 0, 0 is assigned to heart, so your Arduino would understand that you want the heart to appear. And then after that, LCD.write byte 1. 1 is your smiley face. Take note here that your void loop is empty because you don't want your text and characters to sort of like have a blinking effect, right? You just want it to appear on the screen as it is. That's why you only put the majority of your codes in the setup function.